question. Somebody asked me a question about a previous homework. I think we should go over it because maybe you might see it tomorrow. See, you guys might know how to do the problem, but maybe there's a faster way to do it. That's why, even though you get the problem correct, you should ask. Okay, let's go back to linquad5. Number 7. Okay, linquad3 number 7. Good to discuss this. We can get this on a video. So here's the quadratic equation: 4x squared plus 8x plus k equals 0. For what values of k will the equation? No, we're doing part B. For what integer values of k between -10 and 10 will the equation have rational roots? How do you tell if this quadratic equation has rational roots?
B squared.
The discriminant has to be a perfect square. Now, I'm pretty sure you guys did it, right? What's the discriminant? B squared minus 4ac is a perfect square. So 64 minus 16k is equal to a perfect square. So what did you do? You just start plugging in numbers now. -9, -8, -7, all the way to 9. Anybody did something different? See, but then when you plug in -9 and 9, don't you get like large values and then, right? Is there a better way? Yeah. Did you guys notice that you can factor out a 16? And then what's left if you factor out a 16? 4 minus k is a perfect square. But 16 is already a perfect square, so then you just have to look at that. So then all you have to determine is, when is 4 minus k a perfect square? Isn't that a lot easier to plug in? No? Yeah, see, so why do you want to plug, like you plug in -9 there. Can you guys do that quickly in your head? Plug in -9. Because you can't use a calculator. You're not allowed a calculator on this problem. So that's why, factor out the 16 and then it's way easier to plug into this.
So two perfect squares, no matter what, multiplied will turn into a perfect square?
Yeah, is a perfect square times a perfect square equal to a perfect square? Let me look. Yes. Perfect square times a perfect square is a perfect square.
So what if the number wasn't 16?
Oh, then you gotta plug in. But I purposely made it like that so that see if you guys would factor out the 16. But so did anybody factor out the 16? Joe. Chen. Okay, one person. Everybody else befuddled for that. Okay, now we can move on. Oh, I'm looking at this. I see several problems that are going to be in tomorrow's quiz right there. You want me to tell you which ones?
Yeah.
You're supposed to say no.
No.
In fact, no, I'm not going to tell you. Come on. If you did the homework, you should be able to do it. And let me look at this one. I think it's 4 from 3 and 2 from this one. So I think. I don't know. I made it this morning, so I'm going to forget it. Right? All right, number 3. Find the value of k. Oh, okay, I'll tell you right now. This may be on tomorrow's quiz, but the probability is 1 that it is on the test. That's good. Yeah, I'm telling you, so now you know 2 problems on the test. In fact, by the time we get to the test, if you listen to me, I might tell you all 8 problems.
Wow.
But then you got to be able to do it, and it's going to be kicked up a notch. See, when I start you off on an easy one, this is an easy one. Yeah, it's easy. Okay, first of all, what does tangent mean?
A line.
Like if a line is tangent to a parabola, what the heck does that mean? So if this is a parabola, what does it mean the line is tangent to it?
Intersects at
That
one
means
point.
it intersects it at only one point, right? Just like in geometry, if a line is tangent to a circle, then what? It touches the circle at one point, same concept. What do you call a line that intersects a circle at 2 points like that? This is called a tangent line. This line is called, and don't say cotangent like last year. No, no. What do you call a line that intersects a circle at 2 points?
Binary.
A secant line.
Oh, yeah.
Yeah, it was on the SAT. Anyway, so you have two graphs. How do you figure out where two graphs intersect?
Equal to
Yeah, no, that's the layman's term, set them equal to each other. The mathematical term is
Oh.
substitution. So since y is equal to this, you can substitute it for y there, which is of course setting them equal to each other, but that's barbaric. Anyway, what kind of equation is this since it's x squared? What a coincidence, we're studying quadratic equations, right, this chapter. So how do you solve a quadratic equation? What do? You make one side 0. See, this one is easy, the one on the test will be like, same concept, but it's gonna be more difficult. So you make one side 0, and what will tell you how many solutions a quadratic equation has?
Discriminant.
The discriminant. So since we only want one solution, since the line touches the parabola at only one point, the discriminant must be 0. So all you have to do in the test, whatever equation you have here, you just go b squared minus 4ac, and you make that equal to 0. Now, did some of you do like something different? Like you said, well, the only way that this could be one solution is it would have to be a perfect square like that. Some of you did it this way. Every year there's always people that do it. And so since that plus 4x, then it has to be x plus 2 then, right? Which means k has to be negative 4. Now, yeah, that would work for this easy problem, but the one you get on the test, that's not going to work. You know what I'm talking about? You're going to have to make the discriminant equal to 0, because who knows, maybe on the test may not even have numbers. There's always a problem, okay, on my test, there's always going to be like one problem where there's no numbers. You just do it like the same, except you do it with letters. Right? Instead of 4, 5, 6, you might see A, B, C. And so your answer is going to have A, B, and C in there. No, you're going to have to get used to that if you want to take BC calculus, you know. So get into the habit of doing this. The discriminant must be equal to 0, and then all you have to do now is solve for k. So 16 plus 4k equals 0. 4k equal negative 16. K equal negative 4. There you go. Yeah, Mr. Park, that's what I got. Yeah, but I'm telling you, it's not going to work all the time. Just do this. Just do this. Actually, it will work, but then you're going to have to do like a lot more computations and things. All right, next, 5. Write a quadratic function whose zeros are, what's another word for zeros? X-intercept. So the x-intercepts are negative 1 and 3. So did you guys draw a picture? It might help.
Yes.
And a maximum value of 8. So if it has a maximum value, doesn't it mean that it opens downward? If it has a maximum value up here. So if the maximum value is 8, hey, we know the vertex then. What's the vertex? 1, 8, because isn't the vertex always going to be halfway between the two x-intercepts because of symmetry?
Yes.
And again, if you have the vertex, don't you just use vertex form?
Yes.
Yeah, so y, do you guys know vertex form? You're going to need it tomorrow now.
Yes.
Y equals a, x minus 1 squared plus 8. How do I figure out the value of a? Plug in a point. So you can either plug in 3, 0 or negative 1, 0. Which one do you like better?
Negative 1.
Now some of you might be asking, Mr. Park, can I plug in 1, 8? No, you can't. But what's going to happen if you plug in 1 for x and 8 for y?
It's equal to each other.
Yeah, you're going to get 8 equal 8, which is true, but it doesn't help you figure out what a is. So you need to plug in one of these points. Which one you want to do? This one?
Yeah.
Okay, if I plug in 3 for x and 0 for y, what do you got? 0 equals 4a plus 8. Therefore, a equal negative 2. So this is negative 2. Boom, that's the equation of the parabola. Remember, if you know the vertex of the parabola, use vertex form. Morikuni, question.
No, I'm stretching.
You're stretching. It's not a question. Okay, number 6. Oh, the word problems. Okay, you're gonna get, you see those 3 word problems, you're gonna get one of them tomorrow. Which one do you think it is, 6, 7, or 8?
7.
8.
I'm not telling you. Every year, just rotate. No, look, all you gotta do, you wanna make sure you can get it, just make sure you can do it. I'm telling you, one of those 3 is gonna be on tomorrow's quiz. And then gonna have another, we're gonna have a, now the one I put on the test, I think is from linquad5. You're gonna have one word. Maybe this one we'll get 2 word problems this year. A baseball player tries to hit a ball over an outfield fence that is 4 meters high, 120 feet high. The ball did what? But the, I'm assuming everybody read this, right? Write a quadratic function to determine the height of the ball when it reaches the fence. Okay, so here we go. So we set up a coordinate system. So should we put home plate at the origin right here?
No.
Yes.
Yeah, I think that would be good.
What? I thought it's one.
Because we want to find the height of the ball, right?
I thought it's like 0, 1. You know?
Yeah, 0, 1.
Oh yeah, that is home plate. I get it.
Okay, so here is the ball. The ball is hit 1 meter above the ground, right? That's reasonable like that. And then travels in the shape of a parabola, right? You guys in physics know this, right? Kinematics. Okay, whatever. I'm telling you. Or from last year, algebra 2. Okay, do I tell you the coordinates of the vertex? Yes, it says it reaches its maximum height of 30 above a point on the ground that is 60 meters from home plate. So isn't the coordinates of the vertex 60, 30?
Yes.
Now look, do I have enough information to write the equation of this parabola?
Yes.
Yeah, I got the vertex and I got a point. So vertex form, y equal a, x minus 60 squared plus 30. How do I figure out a? Plug in this point. See, it's automatic already. If I plug in 0 there and 1 there, what do you got? 1 equals 3600a plus 30. So therefore, a equals negative 29 over 3600. Did I do that correctly?
Yes.
Of course, I'm the teacher. So the equation of this parabola is y equal negative 29 over 3600 times x minus 60 squared plus 30. Okay, now if this is on tomorrow's quiz, then it's worth 5 points. How many points do I get for writing the parabola
2.
equation? Yeah, I'll give you 2. I'll give you 2. Now let's answer the question. Determine the height of the ball when it reaches the fence. So here's the fence. Okay, how far is the fence from home plate? 110 meters. So how can I find the height of the ball to see if it's a home run or not?
Plug in 110.
Plug in 110 for x. So all you have to do is plug in 110 for x and then solve for y. That's the answer. So if you show me that you plugged in 110 there, I'll give you 1 more point. You want the other 2 points? Compute it without a calculator. Okay, so what do we got? Y equal negative 29 over... Mr. Park, these numbers are crazy. No, they're not. They're not crazy. Look at this. What's 110 minus 60? 50 squared. 2500 plus 30. Can you do this without a calculator? I think you can. Look, the 2 zeros cancel out. So make the least common denominator when you're working with fractions. Hello? Least common denominator?
36.
36. So what do you got? Negative 29 times 25 plus
30 times 36.
30 times 36. Now, how do you compute that without a calculator? What are you going to do? Multiply these 2 numbers, multiply those 2 numbers, and subtract? How about factor? You guys ever heard of factoring? Because it makes the number smaller, that's why. What number can be factored from this and this? 5. Okay, what's going to be left? 5 times 29.
6 times 3.
Oh my goodness. Okay, 29 times 5. I don't know how you guys learned, but when I was in elementary school, my teacher said, think of the 29 as 30 minus 1. And then use the distributive property. So you get 150 minus 5. You can do this in your head. So you get
100.
negative 145. Right? Can everybody do 30 times 5 in their head? Right, so that's why you just go 30 times 5 minus 5. It's called the distributive property. Okay, what happens if you factor out a 5 from this? You get 6. 6 times 6 squared is 6 cubed, and everybody knows 6 cubed is?
216.
Because, come on, when you come out of elementary school, you're supposed to know your square numbers up to 25, right? And you're supposed to know your cube numbers up to 10, right? Okay, 9 cubed.
729.
Okay, one person does.
What?
You're supposed to know that! 8 cubed.
500.
512. See, I guess we don't know it. All over 36. And then, can you do this in your head? What's 216 minus 145? You want me to write it like this then?
71.
71 times 5. Can we do that in here? 71 times 5.
3.
Okay, here, again. Think of 70 as 70 plus 1. See, most people can add in their head better than they can multiply. So just go 350 plus 5. 355. So 355 over 36. Shall we just leave it like that? Yeah! You can't reduce it anymore. So anyway, that's how many meters the ball is. So is that a home run?
No. Sorry, I just
Is that a home run?
Yeah.
Because the fence is what, 4 meters high? So this is 110 comma 4. This is the height the ball is when it reaches the fence. So is that higher than 4?
Yeah.
Do I need my calculator for that? No, that's almost 10. 360 over 36 is 10, right? So it's just a little bit less than 10 meters. So this is a pretty good home run right here. See, we don't need calculator for computations. Don't worry, all my answers are less than 1 million, so you don't have to worry too much. Okay, number 7, another word about now. Last year, the class told me that Mr. Rubash did this exact same problem last year.
Yeah. I looked at his YouTube channel.
I looked at his notes.
Called it.
How about look at my notes? Okay, anyway, you have a barn. Here's a barn. Oh, wait a minute, somebody.
It's 4.
So-
Oh wait, no.
Wait, somebody came in for help and I told them the wrong thing. Watanabe.
Yeah.
Yeah, I didn't realize that, now I noticed that this is a barn. So we don't need fencing for that. Did you fix it?
No, because yeah,
Oh, okay.
that's why I put it on the board.
So barn, I just saw it now.
But it's a
So
wood.
this is the side of the barn, so you don't need to put fencing over there.
So
See, because what you want to do is you want to separate the pigs, the goats, and the sheep, right? Because if they start mingling together, you might get like weird animals. You gotta keep them separate. Anyway, you have 120 feet of fencing available. So look, I even helped you out. Call this X. So this is X, X, and X. And then shall we call this Y? Okay, now what are we trying to do? It says, let's read the problem here. If 120 feet of fencing are available, write the area of the enclosure as a function of X. Okay, now look at this picture. What is the area of this enclosure right here? X times Y. But see, that's a function of 2 variables. We want a function of just X only, because then we can make it a function and then we know how to work with that. So we need to somehow get rid of the Y here. So we need to write another equation. Well, the only other information given is there's 120 feet of fencing available. So that means this plus this plus this plus this plus that got to equal 120 then, right? So 4x plus y got to equal 120. Everybody see that? Solve for y. Y equal 120 minus 4x. Plug it in right down yonder. And now we got a quadratic function. What a surprise, right? That's what we're learning this chapter. So area is equal to x times 120 minus 4x. Okay, that's part A. Part B. Find the value of x so that the area will be a maximum. Now, if you were to graph this, what would the graph be, since this is a quadratic function? It's a parabola opening downward. Is there a maximum value right there, a maximum point? Yeah, that's the vertex. Do we know how to find the vertex? Yeah. So one way to do it is multiply it all out and do negative b over 2a. How many people did that? Okay, that's not bad. What about multiply it all out and then complete the square and put it in vertex form? How many people did that? Or did one person? Okay, then did anybody do it even faster than those 2 ways? Not one person?
Oh my god.
Or including?
The discriminant thing? No.
Yeah, the x-intercepts. Look, the thing is in factored form. That tells you what the x-intercepts are. What are the x-intercepts of this parabola? 0 and 30. Right? So, by symmetry, doesn't the vertex have to occur halfway in between? Yeah, if you do the other two ways, it comes out to 15, but why not do the fastest way? Because I like to do extra work, Mr. Park. Yes, the vertex is going to be halfway in between. So, that means when x is 15, that's going to be the biggest area that you can have here. So, does that answer the question?
You have to
Get
like,
that off your head. Find the value of x. So the answer is 15. The answer is 15. So if you were building this enclosure, you would go 15, 15, 15, 15, and then what would that be?
60.
60. And that's the biggest area that you, because when you build this thing, okay, don't you want your pets or your animals to like have the largest area so they can like roam around?
Yeah.
Because another way to build this would be something like this. You could make it like, it could be like this. Like that, right? But then, do you want to go, all they can do is walk like this, right? They can't roam around. You want a big area.
Wait, Mr. Clark,
Mhm.
why don't you solve for the y? Why is it?
Because it says find the value of x. Now you gotta read the
Oh, oh.
So, but what if tomorrow, okay, what if tomorrow I ask, what is the largest area that you could enclose?
you solve for.
Then you solve for y, because y is the area, right?
Yeah.
So yeah, that's why you gotta read the question. You gotta read the question, that's where we have problems. Number 8. Okay, that's right out of your Algebra 2 book, Lester. Did anybody recognize that problem?
Yeah.
Okay, you're gonna get that almost that same problem on tonight's homework, and who knows, you might see it again on the test. So today we have airline tickets. I think tonight's homework is I forget what it was. And then I remember I put it on the test. I put like Pokemon cards or something in there. I don't know. They just couldn't do it for some reason. Okay, do you guys know what revenue is? What is revenue?
The amount of money.
The amount of money that you bring in. Now, if you're selling airline tickets, how do you compute revenue?
Price times the
The
amount.
price per ticket. Now, normally, what is the price of a ticket? $540. And normally, how many do you sell?
150.
So normally, your revenue would be 540 times 150. But then you realize, hey, every time I reduce this by $2, I can sell one more ticket. So in other words, what if I sold it at $538? I could sell one more ticket. I can sell one more ticket then, right?
Yeah.
So knowing this, is there a way that I can maximize my revenue? Because if you're in business, what do you want to do? Maximize your revenue or minimize it? Okay, so that's what you want to do. This is like a business problem right here. So how do we express this mathematically as a function? Every time this goes down by $2, this goes up by 1. I can sell one more ticket. Yeah, plus or minus 2x. Every time it goes down by an increment of $2, this one goes up by an increment of 1. X is the number of increments then, right? There you go, and what a surprise, it's a quadratic function, that's what we're learning. And if you were to graph this, wouldn't that be a parabola opening downward? Yes, and again, see there's a maximum point here. So what's the fastest way? Multiply it out, complete the square? Put it in vertex form?
Zero.
Multiply it out, negative b over 2a? Don't be ridiculous, look, it's in factored form. Go with the x-intercepts. What are the x-intercepts?
270 and negative
270 and then negative 150, so halfway in between is the vertex. What's halfway in between? Take the average. 60. Okay, so that means when x equals 60, that's the maximum revenue that you're gonna get. Okay, so does that answer the question? Put 60. 60 is the answer then. No, you gotta answer the question. What is the question? What ticket price should you sell it at if you want to maximize your revenue? Well, doesn't this represent the ticket price right there? So if x is 60, what's 540 minus 120? 420. So if you sell your ticket So at $420, that's, you're gonna bring in the maximum amount of money. All right.
Wait. Wait, but what about, what's the difference between the left side and the right side?
This is the price, the cost of the ticket. This is how many tickets you sell.
Oh.
See, every time the price goes down by $2, the number of tickets goes up by 1.
Oh.
Yeah, so that's a quadratic function, yeah.
So on like the quiz, would it always be like one ticket and then the
No.
price gets-
No, change the numbers. Okay, here, but like, let's dumb it down for you. What if I said, every time you reduce this by $5, you can sell 2 more tickets?
Oh my gosh.
5x too.
Yeah, then you just change this to, every time this goes down by $5, what did I, no, I forgot what he said. This goes up, you can sell 2 more tickets. Then you do this then. Why is that gonna throw you off if I change the numbers?
No.
Apparently it looks like it would. But then you do the same thing. Hey, there's a parabola. What are the x-intercepts? 108. Oh my gosh, really gonna get
Negative 75.
Negative 75. So the vertex is gonna occur halfway in between. Take the average. 33/2. Oh gosh, we can't find averages. We add and divide by 2. Anyway, that's what I do on my quiz. Same problem, change the numbers. Come on, if you want to survive in this class, you gotta at least repeat the homework problems. If you can do that, then you'll probably be okay. Okay, today we move on. What time is it? Oh, I thought we were gonna finish early. Not today. So this is the last lecture of the chapter, and then we just have to hone our skills for the test. So what are we learning today? Oh, ooh, oh! No, there's so much to learn today. Okay, so if you know the vertex of a parabola, you use the vertex form, right? But what if I give you points, and you don't know if any of them is the vertex? How do you write the equation of the parabola? So, did you guys learn this before? How many non-collinear points do you need to write the equation of a parabola? That means not all in a straight line, because if 3 points are in a straight line like this, there is no parabola that goes through them. It's just a line. They have to be non-collinear. So like if you have 3, just make 3 non-collinear points. This is exactly 1 parabola that goes through them. So what if I gave you 3 points? Okay, somebody give me 3 points. Go.
75.
1, 1.
Okay,
75.
1, 1, somebody said. 2, comma,
5.
5, and then 3, comma,
7.
7. Are these collinear? How do you tell if they're collinear?
Same slope.
Okay, slope. What's the slope from here to here? 4. What's the slope from there to there?
2.
2. Not collinear then. So there will be 1 parabola that goes, that's a function that goes through these 3 points. Now, do I know if any of those 3 points is the vertex? I mean, maybe one of them is, but we don't know. So we cannot use vertex form. So which form should I use? This one. I guess you guys are not looking at your notes then. So if you don't know which one is the vertex, or you don't know if it's, if you're not given the vertex, use this form. And what do you think I'm going to do with those 3 points?
Plug it
You
in.
just simply plug it in and then solve those 3 equations, 3 variables. Now let's see if you guys pick good points. See, because if you just randomly make points, then A, B, and C are going to come out ghastly. Okay, plug in 1 for x, plug in this point here. Plug in 1 for x and 1 for y. What do you get? 1 equal A plus B plus C. Okay, now watch the way I do it. I go A plus B plus C equal 1. Because that's how you normally see it, right? In algebra 2. Whatever, do whatever you want. Okay, plug in the next point. 4A plus 2B plus C equal 5. I just put the y on that side because it's easier to look at the number on that side, right? And then finally, 9A plus 3b plus c equals, and then all you have, so you write that down on your paper, it'll give you 1 point. You want all the rest, you gotta solve for a, b, and c, so you gotta use your algebra 2 skills. Are we good at solving 3 equations, 3 variables? You bet your bippy we are. I'll tell you right now, this problem is on the test. This is one of the 8. Okay, so if I were me, so again, you have to determine, when you have 3 equations, 3 variables, you have to determine which variable do you want to eliminate. We talked about this before. Now look at them. C. Because if you simply subtract equations from each other, the c's are going to cancel out. So if I were me, this is what I would do. I would go this minus this. This minus this. Okay, here, call this equation 1, 2, and 3. Go 2 minus 1. How come I don't go 1 minus 2? Because you're going to get negative, and you guys know how you guys are with negative numbers of fractions, right? Okay, so 2 minus 1, go, this minus this. 3a plus b equal 4. See how I eliminated the c? Now, you have to involve equation 3, so you can either go 3 minus 1 or 3 minus 2. What do you think? Well, if I were me, I would go 3 minus 2. You know why? Because they're right next to each other, less chance of making mistakes. 3 minus 2, go. 5a plus b equal. Okay, now you got 2 equations, 2 variables. Now it's algebra 1. Which variable should I eliminate? B, because if you simply subtract the equations, b's will cancel out. So go this minus this. 2a equals this minus this. Negative 2. Hey, you guys picked a pretty good one. Hey, equal negative 1. Hey, you guys did it. Well, let's just see. Now, if a is negative 1, like plug in negative 1 for a right there, what is b? 7. B is 7. Everybody got that? And once you figure out a and b, go back up to one of these 3 here to figure out c. Which one looks the easiest? I think the first one, yeah? So if this is negative 1 and that's 7, what is c? C is negative 5. Therefore, the equation of this parabola is y equal negative x squared plus 7x minus 5. There you go. Bam! All you have to do is solve 3 equations, 3 variables. But like I said, you guys should be experts at this. Now, on my test, I'm going to make you go 1 step further. Find the vertex. Find the maximum point. Because isn't this a parabola that opens downward? Yeah. So how do you find the vertex? What's the fastest way? Complete the square.
A,
Negative
B.
a over two.
Negative b over 2a is the fastest. So negative b over 2a, what is that? 7 halves. So we know the x coordinate of the vertex is 7 halves. How do I find the y coordinate? Plug it in. Here we go. So y equals negative 49 fourths plus 49 halves minus 5. Make a least common denominator of 4. Negative 49 plus 98 minus
Wait, is it?
what? No, we did it right. Minus 20. No calculator now. What is 98 minus 69 over 4? Oh, you're going to have to borrow. 98 minus 69.
9.
9. Borrow. 29 over 4. Can you guys repeat something like this on the test?
Yes.
I think you can. I just want to see if you can do the algebra and the number crunching. That's what I want to see. Because when you take the AP exam next year, you only have your calculator for less than half the test, you know. The rest of the test is no calculator. You got to be able to survive with that. Okay, now next thing. Number 3, I'm not gonna tell you how to do it. That's a word problem. I'll give you a hint. The probability of number 3 being on the test, since I'm not gonna quiz you on it, is 0.98. In fact, it just went up to 0.99. Okay, now, You guys had your graphing calculator from last year? What was the most important thing you learned about your graphing calculator last year?
It's
You can solve any equation on your calculator, any equation. Did you guys learn how to do that? What? Okay, here, let's solve an equation. Give me something. No, not linear equation, something like that's crazy.
7, 9,
Something that you can't solve by hand.
1748.
What? That's just ugly numbers.
A quadratic?
Okay, how about a quadratic and an exponential then?
Oh.
Yeah, that's the ticket. Shh, okay, I'm trying to think. Okay, how about 3 to the x is equal to, wait, shh. Wait. 4 minus x squared then. How do you solve any equation on your calculator? Now this one you cannot solve by hand, you cannot. Okay, you have to use your calculator. How do you solve any equation on your calculator? You guys looking at the notes? It's in the notes. You make, the first step is to make one side 0. 3 to the x, make one side 0. Minus 4 plus x squared equals 0. And then what you do is you graph this. So you graph y equals this. So take out your calculator and graph this.
In function?
Yeah, go to function mode and graph it. You guys never learned this last year then? What? Why do you guys even have it then? That's like the most important thing. What did you guys use it for last year? To add 3 plus 4 and you get 7.
To check our answers.
It's like 3 plus 4 is 7.
Yes.
Oh yeah, it is.
You know, like
Did you guys even use it to graph? Oh, that looks
Yeah.
weird.
to check our.
Did you guys use it to like at least, what can you do? Not just draw graphs, find points of intersection?
Wait, so you cannot even solve that?
No, you can't do it by hand. You have to use your graphing calculator.
Like us or just anyone in general?
Anyone in general. Because that's an exponential function and that's a polynomial function. Okay.
Oh, I don't.
That's like mating goats with sheep. You know what's gonna happen.
Isn't the same thing?
You can find the extreme one.
Okay, so if you graph this on your calculator, this is what I'm seeing on Park's calculator. I'm seeing this. Right?
Oh.
Everybody got that?
Wait. The vertex is on the other.
No, that's not a vertex.
Oh.
Time out. Okay, true or false, that's the vertex of the parabola. No, that's not even a parabola.
Oh.
See, in my calculus class, they think any U-shaped thing is a parabola. Do you guys think that?
Yeah.
Okay, see, that's the problem. A parabola has to have a certain equation, and you know what that equation is? That. If that's not the equation, it's not a parabola. How many of you have heard of the city St. Louis? Have you been there?
Yeah, oh no.
The Gateway Arch. You ever heard of the Gateway Arch in St. Louis?
Yes.
That's a U-shaped thing. Is that a parabola?
Yeah.
No, it's not. It's actually a hyperbolic cosine function. That's what it is. So, okay, erase that from your memory. Any U-shaped thing is a parabola. No. This is a U-shaped thing. That is not a parabola. How come this is not a parabola? Because it doesn't have the quadratic form. That's why. Oh my goodness. Okay, question.
What?
It doesn't,
No, go, go.
Yours doesn't graph?
no.
How come? Okay, did you go to function and you type
I
this in?
said the same thing as this is. but
Okay, let me
it's
see what
like-
happens. What did you do? Play games? You guys are playing games on your calculator?
My calculator won't even turn on.
What? You can't even turn it on? What's are you gonna do tomorrow?
I'm gonna go to see that.
Oh, Mrs. Yonachir.
Yeah.
Wait, what class are you?
Go like this.
W213. So you can't even graph it? Your window, that's why. How come the window has changed?
What's a window?
The window, like X min, X max, Y min, Y max.
X-Men.
The normal window goes from negative 10 to 10 on the X and negative 10 to 10 on the Y. But if you're playing games and things, then maybe it changed.
Okay, you.
So are we in function mode right now? Are we in function mode right now?
Yeah.
Okay, how did you get to the escape then?
How do you get rid of those?
Wait, that's
Okay, so did you do it symbolic?
I
Okay, detected
Start.
incorrectly.
You have to go.
Okay, what about the window? Okay, you guys know how to change the window? I can't even read this thing.
Isn't it like shift?
The window.
Isn't it like shift num or something? Huh?
What is the window?
Okay, here, let's go to plot. Okay, shift plot. There you go, shift plot, window. See, your window settings are so terrible that you can't even see the graph on the
And
screen.
then you go to function and then.
See, look, see, this is what you should see, but if your window is not set correctly, what if your window is right there? Mr. Park, I don't see anything. You want your window here. You know what I'm talking about?
How do you
Yeah.
change that again?
History
What is the
class.
window?
Shift
What is
plot.
the
Okay, now,
Then shift queen.
Mrs. Yonashiro told me you guys can pinch it, what do you call that? Pinching, and what's the opposite of pinching?
Squishing.
No, that's pinching. Pinching and unpinching.
Spread.
Okay, I don't like that. How about just change the window? Go to second plot and make the window. You go negative 10 to 10, negative 10 to 10, and then
What is that?
you can
See,
do
I
that. That's
press
we
auto
can
scale.
manually set the window
Where's that?
instead of pinching and unpinching.
Is this function faster than? No.
Is it view? Oh, is it
Split
split screen plot table?
It's because I
Is it
pressed
setup?
auto scale.
How you doing there,
That's what he
Andrew?
told us to do
Oh,
last
okay.
year, we couldn't see it right.
Hmm?
He told us
Who
to
told
change
you
it.
this?
Mr.
Mr. Rubash,
Gone.
auto scale.
Oh.
But do you know what auto scale does? Obviously not, so don't do it.
Is this the thing?
Yeah, that's the window.
And then you just do 10, 10.
Okay, so like on most graphic calculators, we have like a standard screen. So normally we just go V window standard on the old calculator, and it would go negative 10 to 10 on the X and negative 10 to 10 on the Y. And then maybe after that, then you can start pinching and unpinching. How's that? Anyway, to solve this equation, what are we looking for? We want, no, we're not extrematizing it. Look, equals 0.
Oh, X intercept.
That means when the y coordinate is 0. That means when the graph touches the x-axis. These are your answers. That means there's going to be two real answers. Okay? So how do I find these two answers? What do I do once I see this on the screen?
Average
You
it.
press menu,
Open.
function,
Root.
and then you press root. Oh, wait, time out. Before you do that, you have to move the cursor close to this one because you have more than one. So use the left and right arrow to move the cursor close to this one. And then go menu, function, root. And boom, it'll give you this to 3 decimal places. Well, you give me 3 decimal places, your calculator gives more. So what's the negative?
1.971.
Everybody got that? And then now, move the cursor close to this one and do the same thing. Menu, function, root.
This is 1.
Wait.
It's exactly 1?
Yeah.
Yes.
Oh, it is. Look at that. Because if you plug in 1, you get 3 minus 4 plus 1, which is 0.
Wow.
Oh.
Good number.
Yeah, but this one you could guess and check, but you can guess and check that one.
Wait, so they have to get a second one?
You gotta move the cursor close to that point. Use the right arrow. Use the right arrow. Move the cursor close. You know that what do you call this thing? The
Oh.
cursor. It's not the cursor. The crosshairs. What did Mr. Rubash call it?
Nothing.
The crosshair. No, she just said it's Mr. Rubash.
What about proxy?
The plus
Yeah,
sign.
proxy
Plus
matters
sign.
too. Proxy matters too.
Okay, move the crosshair close to there and then go menu, function, root. You can solve any equation because these kinds of equations, you don't know how many solutions there are until you actually draw the graph. If it crosses the x-axis 10 times, then get 10 solutions. This one apparently only has 2. You know what I'm talking about? So what we're looking for is where does the graph cross the x-axis? Now, of course, another way to do it would be draw this graph and draw that graph like this. What does 3 to the x look like? Okay, I'll tell you, something like that. What does 4 minus x squared look like? It looks like this, right? Parabola opening down. There's 2 points of intersection. So another way to do it is to draw both graphs and then just find where they intersect. Yeah, because then you're going to draw 2 graphs, right? And then,
Yeah.
depending on your window, what if this point is like off the screen? What are you going to do?
Open your window.
Don't press auto scale.
No, that's why it's better to make one side 0 because everybody knows where the x-axis is, right? Yeah, so that's why I like that one better. Yeah,
So there's
question.
no way we can solve this ourselves?
By hand, without a calculator.
Yeah.
No, can't, because I told you, that's an exponential function, that's polynomial, it's like, they don't coexist together very well.
What's the probability of this being?
Well, since I'm not, see, normally I would put this problem on, normally I would give you number 3 with the numbers changed on the quiz, but then we didn't get that far, so I'm gonna have to put it on the test. There, I just told you,
This way?
the probability that number 3 is on the test, I tell you it's 0.9, in fact it just went up to 0.995. Hey, if you listen to me, maybe you're gonna actually know the entire test by the time we get
Wait, so is there like a potential that there's like something that you say you're gonna put on the test isn't gonna be on the test?
No, if I tell you it's on the test, it's on the test. Okay, one last thing before you leave. Look at number 5. Did you ever see a problem like that?
No.
Well, if you're on the math team, you did. If you're not on the math team, okay, I'm gonna do a different problem then. What is the square root of 6 plus the square root of 6 plus the square root of 6 forever? And you keep on going forever. How do
Find the
you-
pattern.
Okay, without a calculator. What is this number? Anybody want to take a guess? Okay. Okay, we don't know what this number, and the reason why we can actually do, look, hint. I give you a hint there. Let this given expression be equal to x. I don't know what this number is, Mr. Park, I'm gonna call it x. Now, the reason why you can do this easily is because it goes on forever. If it didn't go on forever, then it would be difficult. But since it goes on forever, easy. So tell me, what is x? The square root of 6 plus the square root of 6 plus the square root of 6 forever, right?
Yeah.
Okay, now watch this is the key. What did I just circle? That's x! That's the square root of 6 plus the square root of 6 plus the square root of 6 forever.
Oh.
You guys get it?
Oh.
So then, so that's the same thing as the square root of 6 plus, that's x, and that's equal to x.
Oh.
And then what happens when you square both sides?
It comes.
It's a,
What a surprise! You got a quadratic equation. That's what we're studying.
Wow, that's awesome.
I will leave the solving to you,
How
but
is that possible?
how is that possible? Okay, you know what? I want to show you. I want to show you. Make one side 0. Hey, Mr. Park, big factor. So x equals 3 or negative 2. Now, look at the original problem. Do you think this? What is the square root of 6? Isn't it 2 point something?
Yes.
So if you have the square root of 6 and you're adding things to it, shouldn't the answer be bigger than the square root of 6?
Yeah.
Which of these answers is bigger than the square root of 6?
3.
The answer is 3, so you gotta cross out that one. So if you keep on doing this forever, you get exactly 3. Isn't that amazing? How is that possible? We're done with linquad.
No, don't we have?
We have
We have 5 and 6.
No!